Imagine a world where everything you see and touch is an illusion. A world where reality, as we know it, is just a holographic projection from a distant two-dimensional surface. This is not the plot of a science fiction movie, but a scientific concept that is gaining traction among physicists, the holographic universe theory. The idea might seem ludicrous at first. How can our three-dimensional world with its depth and texture be a mere projection? The answer, physicists believe, might lie in the strange world of black holes and the even stranger realm of quantum mechanics. The holographic principle suggests that the information about our universe's three-dimensional reality could be encoded on a two-dimensional surface at its boundary, much like a hologram. This mind-boggling concept challenges the very foundation of our understanding of the universe. What if our perception of reality is nothing more than an elaborate holographic projection? This essay delves into the fascinating world of the holographic universe, exploring its origins, the science behind it, and the profound implications it holds for our understanding of the cosmos and our place within it. The seeds of the holographic principle were sown in the enigmatic world of black holes. These cosmic behemoths, with their immense gravitational pull, have long captivated the imagination of scientists and the public alike. In the 1970s, physicist Stephen Hawking made a startling discovery. Black holes aren't entirely black. They emit a faint radiation, now known as Hawking radiation, which carries away energy and causes the black hole to slowly evaporate. This discovery posed a significant problem. If black holes evaporate, what happens to all the information they swallowed? According to the laws of physics, information cannot be destroyed. This conundrum, known as the black hole information paradox, puzzled physicists for decades. In the mid-1990s, physicists Gerard Hooft and Leonard Susskind independently proposed a radical solution. They suggested that the information swallowed by a black hole is not lost but encoded on its event horizon, the boundary beyond which nothing, not even light, can escape. Hooft and Susskind's proposal had profound implications that extended far beyond the enigmatic realm of black holes. They realized that the same principle could apply to the universe. Just like a black hole, our universe has a boundary, albeit an expanding one. What if, they proposed, the information about everything in our three-dimensional universe is encoded on this two-dimensional boundary? This radical idea formed the basis of the holographic principle. It suggests that our perception of the universe as three-dimensional could be an illusion. The true fundamental reality might be a two-dimensional surface, with our three-dimensional world being a holographic projection of the information encoded on it. The holographic principle, if true, would revolutionize our understanding of the universe. It would imply that space and time, the very fabric of our reality, are not fundamental but emergent properties arising from a deeper, two-dimensional reality. To understand the holographic principle, it's helpful to think of a regular hologram. A hologram is a three-dimensional image created by projecting light onto a two-dimensional surface. The information about the three-dimensional image is encoded in the pattern of light interference on the two-dimensional surface. When viewed under the right conditions, this interference pattern recreates the perception of a three-dimensional object. The holographic principle suggests that our universe operates in a similar way. The information about everything in our three-dimensional universe, including ourselves, could be encoded on a distant two-dimensional surface. This surface acts like a cosmic hologram, projecting our three-dimensional reality. Just as the interference pattern on a hologram determines the three-dimensional image, the information encoded on the two-dimensional surface determines the properties of our universe. Everything we see, touch, and experience could be a manifestation of this encoded information. While the holographic principle is a compelling theory, it's important to note that it remains just that, a theory. Direct experimental evidence supporting the holographic principle is still lacking. However, some indirect evidence suggests that the holographic principle might be on the right track. For instance, studies of black holes and their thermodynamic properties have provided tantalizing hints that support the idea of information being encoded on their event horizons. Moreover, the holographic principle has found surprising applications in other areas of physics, such as string theory and condensed matter physics. These connections further strengthen the case for the holographic principle, suggesting that it might hold the key to a deeper understanding of the universe. Despite these promising leads, the holographic principle remains a topic of intense debate among physicists. Some researchers remain skeptical, pointing to the lack of direct experimental evidence. Others are more optimistic, viewing the holographic principle as a radical but potentially revolutionary idea that could unlock the secrets of the universe. The implications of the holographic universe are as profound as they are mind-boggling. If our universe is indeed a hologram, it would mean that our perception of reality is fundamentally flawed. Space and time, the very foundation of our existence, would be mere illusions, emergent properties of a deeper two-dimensional reality. The holographic principle, if true, would force us to rethink our place in the cosmos. We would no longer be independent beings inhabiting a vast three-dimensional universe. Instead, we would be intrinsically connected to everything else in the universe, our very existence intertwined with the information encoded on a distant, two-dimensional surface. While the holographic principle raises more questions than it answers, it has opened up new avenues of inquiry in physics and cosmology. Researchers are actively exploring the theoretical underpinnings of the principle, searching for experimental tests that could prove or disprove its validity. The quest to understand the holographic universe is still in its infancy. However, the journey promises to be as exciting as the destination, potentially leading us to a profound paradigm shift in our understanding of the universe and our place within it.